Welcome, Compton. So good to have you at the Earth Keepers Summit, and it's a treat to speak with you as always. And Compton is a microbiologist, and he's really one of the leading experts in the world in the microbiome and this community of bacteria that we have in our gut and the bacteria that have made life in this planet possible. Good to have you here, Compton.
Yeah, thank you, Alberto. I'm glad to be here.
And Compton, you and I have been speaking about the extinction event that's happening with the little creatures that we cannot see. Can you tell us a little bit about them? Who are they? Where do they live? And why are they so important?
Well, absolutely. The little creatures that I'm speaking of, that is a mass extinction event, is the microbes in our gut. And who are they? They're the major components of the human ecosystem. And science have shown that, out of over 110 trillion cells estimated that live in the human body, over 90% are microbes. So we're only 10% human cells. And then when we look at on the DNA level, 98% of all the DNA in the human body and the human ecosystem is represented by microbes. And we're finding out that over the years, with the way that we farm our foods, and we created a food system where we're literally only getting a very small variety of foods. We're losing diversity in the microbes in our gut, a great diversity, and it's called the mass extinction event. And we see that in the rise in chronic diseases, for example. IBS, Crohn's disease, asthma, for example, a lot of colorectal cancer, things like that can be attributed directly to a lack of not just microbes in the gut, but the diversity of microbes in the gut.
Yeah, absolutely. I mean, we're seeing the extinction events at the big scale, the mammals that are becoming extinct, that are threatened. We're discovering new species every day, but there are many more species that are dying off. But you're talking about the invisible ones, that you cannot see. Tell us how did they make the earth inhabitable? How did they allow for life to occur in the earth? Can you give us kind of the big perspective, the biological perspective?
Right. So let's consider the Earth is 4 billion years old. And for 1 billion years, the scientists have estimated that nothing lived on this Earth because it was just so hot. It was a big red fireball, and some event happened where the Earth started collecting water, and we became a terrestrial planet. And the first organisms that came on this Earth were microorganisms. And they started living here when the Earth was 1 billion years old. And microbes, when I talk about microbes, we're talking about, from a human perspective, living organisms that cannot be seen by the human eye. And to them, they're not microbes. They're big organisms. We are macrobes to them. And they consisted of bacteria, which are prokaryotes. They consisted of viruses, and viruses lived on the bacteria. And they actually came from space. And they're finding out now that 99% of all the space particles floating in space are bacterial spores. And they came to Earth. They inhabited Earth. And for 2 billion years, from the time that Earth was 1 billion years old to 3 billion years old, we just had microbes on this Earth, and all they cared about is, can I eat you, and can you eat me, and what can I eat? And they were basically eating the minerals of the Earth and each other. It wasn't until the first eukaryote came on the Earth, and eukaryotes are vastly different from prokaryotes, because eukaryotes means a true nucleus. And these microbes were actually the blue-green algae. And, we could barely see these algae with the human eye. And they came aboard when the Earth was about 3 billion years old, and they started making oxygen into the air, the blue-green algae. And they are responsible for creating 70% of all the oxygen on the earth. It's not the trees, they're microbes, and they're the blue-green algae. And I hypothesized that they actually made a deal with these microbes that were not able to grow in the presence of oxygen. They were strict anaerobes. And at that time, the earth was an anaerobic environment. And it wasn't CO2, it was actually methane that was prevalent in the atmosphere of the earth. And with the volcanoes exploding and everything, there was no oxygen on the earth. And the microbes were eating each other. This new type of microbe, the eukaryotic microbes, came in. They started making oxygen in the air in plenty amounts. And what it did, it started to poison the strict anaerobes in the microbes. So, they made a deal with each other. And to this day, this deal is being kept. And I call this the sacred agreement. And that agreement was that these strict anaerobes told the eukaryotic microbes, they said, yeah, you can live here on this earth as long as you serve me. And I liken it to, the time where I changed schools when I was in the 6th grade, and I came from a bigger city, and I moved to a smaller city thinking that, hey, I'm in the 6th grade, I'm older than these kids, and I can tell them what to do. And lo and behold, as soon as I went into, this brand new school, I had another thing coming. I didn't know who the good kids were, who the bad kids were. I literally had to be subservient to the kids in the school to get along with the school. And that's basically what happened with these eukaryotic blue-green algae. When they came into this world, they had to be subservient to the strict anaerobes and said, how can I serve you in order for you not to eat me so I can flourish in this world? Fast forward to the time where we're human beings. What they did was, the agreement was that these strict anaerobes would live inside these aerobic organisms, and these aerobic organisms fed them first. They said, you'll live inside of us, we'll give you a protection model, and we'll protect you from the oxygen in the air, and you can live inside us, and we'll feed you. And not only will we feed you, we'll be your car. So you don't have to move around. We'll funnel food into you. And to this day, every single eukaryote, which includes the blue-green algae, the trees, the insects, the bees, they all have microbes inside them, and they all have strict anaerobes inside them. In the human gut, when we talk about the microbes and we talk about the probiotics in the human gut, 99%, if you look at the human gut as an iceberg, only 1% of the human gut has aerobic organisms. And we're talking about the ones that we have at probiotics, the lactobacillus, the bifidobacterium, the yeast. They only comprise 1% of all the 99% in our human gut. 99% that live underneath the oxygen in the human gut are strict anaerobes, and they're completely protected by our colon. Yeah.
So just to be clear on this, what an anaerobe is, a non-oxygen breather. So you're saying 99% of our gut bacteria are non-oxygen breathers that are beneath the surface of the aerobic bacteria that are what we call probiotics. So that really 99% of the colony is non-oxygen breathers that our probiotics cannot get to, right?
That's correct. Like, we can't culture them. I mean, we still don't have the technology to culture 99% of these bacteria. The $87 billion market that we call the probiotic market is only feeding 1% of our gut. And I know this comes to a shock to many, but, we're going around trying to figure out, which lactobacillus, which bifidobacterium, which probiotic to take, and we're trying to make all these decisions, and we're going crazy with just only 1% of our gut. Just imagine when we start to create our second generation probiotics, when science catches up and technology catches up to the fact that we have to start taking and we start culturing these strict anaerobes, which we can't do yet. we've got about 1,700 different species of these strict anaerobes that we have to pay attention to. We have no idea what they do. We have no idea which one of those bacteria are important. And we're just having a hard enough time dealing with just three: the lactobacilli and the bifidobacterium and the yeast. And with the lactobacterium, there's a plethora of different subspecies, and with the bifidobacterium, there's a plethora of different subspecies. But we're all going nuts trying to figure out which ones are which, right? But there's an answer to that. The key is in trying to figure out which microbes control the other microbes. And have you heard of the concept of keystone microbes, Alberto?
Yeah, I've heard of the keystone species. I didn't know that we had keystone microbes. I knew that elephants, for example, are a keystone species because they create ecosystems. Bees are another keystone species. The krill in Antarctica. I was just in Antarctica recently. They're also keystone species that are really is the wolf, right? The wolf is another one of these.
Yes. So keystone species in the macro world are species of animals by which, if you remove them from the ecosystem just starts to go crazy, and it actually de-diversifies the ecosystem. So there's three different kinds. There's the predators represented by the wolves, by the orcas in the ocean, the eagles up in the air, and then there's the prey, like the Antarctic krill, like you said, the prairie dogs in Colorado, and there's actually sanitation engineers like the starfish. The starfish were actually the first organisms denoted as keystone species because they literally clean up the bottoms of the ocean, and when they're allowed to thrive, they clean up the bottom of the ocean. They eat up a lot of the dead vegetation, and it allows the bacterial species, the ecological diversity of the ocean to grow.
So
but the most important, go ahead.
When I remember was it in Yellowstone that they took the wolves out of Yellowstone, and the
right.
whole system went out of balance and they were reintroduced again? Give us that example, because I think that's going to help illustrate what happens when this keystone species die-off is happening inside our gut and inside the earth.
Okay, so in Yellowstone, there were actually two keystone species that were affected when the ranchers basically begged Congress to eliminate the wolves because they were eating all the the calves and depleting their ranch of all their animals. So when they took the wolves down and they started trapping the wolves, a phenomenon occurred, and they started these predator animals. They were gone, so the elk population and the deer population suddenly rose to outrageous populations. And what happens is they started eating all the plants in Yellowstone. And when they started eating all the plants, they started eating all the shoots. There was no food for the beavers to eat. And so the beaver population started going down. And those two species were responsible for Yellowstone's diversity of animals going down, because the deer and the elk started eating all the plant matter. And there was also no food for the beavers. The beavers is the most important keystone species in North America. Just like the elephants, they're called ecosystem engineers, and they're the ones responsible for damming up the rivers. And once you dam up the rivers, the water flows on the side and you got diversity of plants. And when you get the diversity of plants, you got the birds, you got the bees, you got everything. Every time the land introduces beavers back into the land and inside the western part of the United States, the bacterial species, the microbial species, the ecological diversity starts to increase about 1,000%. And so with Yellowstone, they reintroduced the wolves back into Yellowstone. They put down the population of elk and deer, and all of a sudden the beaver population started to go up. And as soon as the beaver population started to go up, the microbial species started to go up into the soil, the plant species started to go up, the birds came back, the beasts came back, and it was amazing. So the important thing to note from that is that scientists didn't have to do anything. They didn't have to say, okay, we need to reintroduce this bee population. We have to reintroduce this plant, right? The most important aspect of reintroducing the keystone species is the keystone species are self-governing. They're the ones responsible for developing the social relationships and developing the diversity inside the ecosystem. And what's funny is the longest running study of happiness was just published a few years ago. And this study studied about, it kept track of over 3,000 people since 1937. And you know what the key to happiness was? It wasn't their diet, wasn't their exercise. The key to happiness is in developing social relationships. That was the key to happiness.
Yeah.
Key to longevity was happiness. It wasn't necessarily your exercise. It was how deep and how nourished your social relationships are. Yeah. The keystone species are the ones responsible for developing all the social relationships in an ecosystem. And as above and as it's so below, there are keystone species above.
Vanishing. They're facing an extinction event as well that's endangering our health, our gut health, and our systemic health, and the balance of the community. So these are social relationship managers. This is this amazing community that we think is us, but that's really 98% them are not getting along with each other, right?
That's right.
And that's happening in the earth as well, with some of the keystone microbes disappearing. Take us there, would you?
So, what's killing off the keystone microbes is the fact that we think it's our responsibility to nourish and fertilize the earth and the soil. And it's not our responsibility at all. They can do it themselves. The microbes have been here. They were here for 2 billion years. I mean, eukaryotes, we've only been here at most 1 billion years, and the microbes have been here for 3 billion years. I mean, they know how to take care and nourish this earth a lot longer than we do, and we need to give them the credence that we don't give them.
But what's going to happen then to the fertilizer industry? What's going to happen to the companies that make the pesticides that we feel we need to protect our foods? So you're saying that the microbes can do this even more efficiently than we can?
I do, yes. And if they don't change their ways, they're going to be disintermediated, just like the internet disintermediated travel agents, for example, and disintermediated all the middleman brokers, right? Unless the food industry, the fertilizer industry, the pharma industry recognize the intelligence, the biological intelligence of this earth and learn to work with them as opposed to working against them, they're going to be disintermediated. Maybe not in my lifetime, in your lifetime, but maybe 2 or 3 lifetimes away from us. I mean, human beings may be disintermediated if we don't look at how the microbes serve this earth and how the microbes really control this earth. Let me give you an example of microbial intelligence. We're all thinking that artificial intelligence is the way to go now. So we give our minds away to this cloud, this AI cloud called Google. And we think that, we can't write articles without ChatGPT or whatever. But in actuality, the AI, the silicon-based machines are actually trying to go carbon-based. They're trying to go like us. Eventually, they want to be like humans. They want to be sentient. Why is that? It's because the evolution of artificial intelligence is eventually going to be carbon-based, and it's going to be biological intelligence. Let me give you an example. Silica and computers only have 2 nodes of intelligence, right? It's a binary system. You got 0 and you got 1. The minimum amount of intelligence in bacteria have 5 nodes of intelligence. And that's the E. coli in our gut. It has 5 nodes of intelligence. Therefore, you have 0, 1, 2, 3, and 4 to play around with. Right now, computers, we just have 0 and 1. So we do all of our calculations with just a combination of 0 and 1s. That's basically 16, right? But with E. coli, they've got 5 nodes of intelligence. In the soil, in conventional soil, we've got this bacteria called azotobacter. It's a nitrogen-fixing bacteria. It has 16 nodes of intelligence. And it's so capable of complex decision-making models that scientists have incorporated these microbes inside chips, and they're called quorum sensing chips. They've been working on it since 2014. They can make chips so intelligent now by incorporating bacterial DNA and bacterial genes that they're using these chips for Las Vegas. They're the chips that actually determine what the line scores are in gambling. That's why when they say, this football game is going to be at this particular score, you either bet above it or below it. Why does the house always win? Because they know exactly what the score is going to be in that game. And that's done through these biological chips. Okay, so we're talking from 2 nodes of intelligence to 16 nodes of intelligence. But it doesn't even stop there. There's this soil in the Amazon called Terra preta and Terra mulata that's been growing, and it's been alive for over 5,000 years. It was considered the black gold by Cortez and the Spanish conquistador, because this soil supported over 30 million people in the basin of the Amazon, and that soil still grows today. And it's a man-made soil, but it's really rich in these microbes. And these microbes are growing basically on biochar. They burnt wood and they buried the wood and they made this biochar. And this biochar serves as these homes for these microbes. And the fertilizer from this terra preta soil is so rich that it supported over 30 million people. And the wild thing is, it's all man-made. The wild thing is the surrounding soil is so nutrient deficient that the microbes that were growing in this biochar was enough to hold the carbon, nitrogen, potassium, and keep the alkalinity so high that it started to grow on its own. So when you actually take this soil out and you pull it out, it still grows, okay? When scientists pulled the microbes out of this terra preta soil, guess how many nodes of intelligence the highest microbe had? 48.
Wow. Well, and Compton, take us back to the human gut. We only have a few minutes left. How is the species extinction event affecting our health by destroying the populations in our gut?
Well, the species extinction event is because we don't have the proper microbes that in our gut, and honestly, we don't have to take the probiotics, because they're aerobic probiotics. They only represent 1% of our probiotics. We have to take what I'm calling super fertilizers, the boosters that actually start our innate strict anaerobes to grow in our gut. And the best way to do that is by taking a diversity of food nutrients. And we have to diversify the food nutrients. And people say, oh, I'm diversified. I eat broccoli, I eat corn, I eat, all these prebiotic fibers, which are good. But honestly, in the United States, we only have basically 1 or 2 species of broccoli that we're eating, and we have 1 species of Brussels sprouts that we're eating. So we're not eating a diversity of all these wild grown crops from around the world. And these microbes thrive on prebiotics, they thrive on flavonoids, they thrive on polyphenols, you know. So when I snack, you know, you want to eat these fruits that are the rainbow color fruits. You want to eat raspberries, you want to eat blueberries, nuts, you know, cacao and cocoa. They're just really rich in polyphenols and polyflavonoids. I mean, polyphenols and flavonoids that they're the super fertilizers for these keystone microbes in the gut. And once you start the keystone microbes moving in the gut, they're the ones responsible for diversifying the ecological species in the gut.
I know, Compton, that you're the CEO of a probiotics company, of a boutique probiotics company that caters to the top athletes around the world, the top sports teams, the in very limited production, Ascended Health, and this is where you're focusing, right? And you're focusing not only on the bugs, but in the superfoods that are going to support their managing the ecosystem of your gut and your health. Am I wording that correctly?
Yes, yes. And not only I'm focusing on reestablishing the keystone microbes in the gut. So the keystone microbes in and of themselves, there's something higher intelligent they're doing. What they're doing is they're capable of aligning what I call the gut, heart, brain axis. And with the professional football players and the hockey players and the soccer players that I'm working with, I'm actually preventing them from getting destroyed by all the concussions they're getting hit in the head. And we're actually showing that their brains are bouncing back from these concussions so much faster because of the diversity of keystone microbes in the gut. And they're actually aligning the gut-heart-brain axis.
Beautiful. I think that this is the cutting edge of the biological sciences and of the sustainable relationship that we have with our internal environment and with our external environment. And Compton, thank you very much for being with us at the Earthkeeper Summit. Let's take care of the little ones, of the invisible ones, and they will take care of us. Okay.
Thank you.